Hello, AP Statistics. So we are going to make another kind of numerical graph. We've already talked about dot plots, and a dot plot is great for small sets of data. Another thing that's great about dot plots is when you have several instances of one value. Like I have a lot of fives, but that doesn't always happen. So if your data points are spread over a larger range, and you have maybe more data, you might not want to make a dot plot. Instead, you may say, well, I don't have a lot of 12s, but I do have a 12 and a 12.2 and a 12.3 and a 12.4, and I want to kind of group those similar values together. So in that case, we're going to make something called a stem plot. Stem plots are great for small to medium sets of data, just like dot plots are great for a small amount of data. Neither one of these you would really want to use for a huge pile of data. That's more suited for a histogram instead. When you make a stem plot, you're going to see a couple of features. The first is that it always is going to have a key to teach you how to read it. So in this case, the key says 14/2, or a stem of 14 and a leaf of 2 means 14.2 seconds. So when I go and look at some of these values, I see this is going to be 12.2 seconds, 12.6 seconds, 3.0 seconds, 3.2 seconds, 13.5 seconds, 14.1, 14.2, 14.4, etc. All right, so the other thing that the other thing that we want to think about is that the leaves are always going to be single digits. So over here, we're only using one digit as the leaf. Notice that we don't have commas or decimals over here. If you do have a decimal place, you will deal with that in the key itself. The other thing is that we really want these to preferably be in order. If they're in order, the leaves are in order, in numerical order, 1, 2, 4, 6, 8, for example, that makes it easier to find the median, but it's not required for them to be in the order from least to greatest. That's the preference, but you can still get a lot of information from a stem plot, even if you don't take the time to put your numbers in order. For example, you can still see shape. You can still see if there's any outliers. You can still see basically what the spread is. What you got to be a little more careful of is carefully identifying from the graph itself things like where the median is. All right. Another thing about our graph is our stems. We preferably want to use about 4 to 15 stems. Any less than 4 stems and you have not enough number line to really see any good kind of distribution. And when you start getting over 15 stems, it just gets to be too overbearingly many stems. You only have single values. You can't really see a trend either. Now, this is really more of a guideline. It's not incorrect if your graph has 16 stems instead of 15, but it's just kind of what we shoot for as a general guideline. Another thing that we're going to do when we make our stem plot, we're always going to make sure we have context in there. So you're going to want maybe the unit of measurement, or you want to mention the variable. For example, race running times in seconds. You want to have that as part of your stem plot. All right, so let's make an easy stem plot here. And I'm going to treat this from scratch as if you've basically never seen a stem plot before and give you a strategy for making it so that if you have a more difficult graph, you can still make your, you make this work. All right, so I'm going to start off, and just like with before, I am going to find the lowest number and the highest number. So in this picture, let's see, 42 and 100, that's my lowest and highest number. Construct a stem and leaf plot for the following list of grades on a recent test. So the lowest grade is 42, the highest is 100. And I'm going to do a little bit of planning work over here on the side. This isn't actually part of my answer. I'm just trying to strategize my way through this. All right, so what I'm going to do first, and what I'd recommend, is that you take your numbers and you start off by lining them up like you were in grade school, and like you would add the numbers. So you're going to line up the ones, you're going to line up the fours, you're going to line up, the hundreds. Notice that this other number doesn't have a value in the hundreds place, so we're going to line that up with a 0. We're going to fill it in so they all have the same number of digits. Okay? Next, when you're done, you're going to think about what would this look like if I sliced off. Now, a lot of people were taught to just hack off the last number and use it as the leaf. We're not going to do that. Well, we are in this problem, but we're going to think from left to right. So I'm going to start off and I'm going to think, what if I used the hundreds place as my stem? What would that look like? So that would give me stems of 0 and 1. That's not enough stems. That's only 2 stems. All right, so that's not going to work. Now, what if I use these numbers again, 0, 4, 2, and 1, 0, 0. And again, what if I took the first 2 digits? Or in other words, I make the tens spot the stem, and I make the 1 spot the leaf. And when I do this, this is going to give me stems of 4 through 10, and that's the right number of stems, because that's going to be 7 values. That's perfect in that sort of 4 to 15 range. All right, so I'm going to go over and I'm going to write stems, okay, and leaf. And I'm going to write all the numbers from 4 to 10. So even if I don't necessarily have any numbers in the 50s or 60s, for example, I still have to include all of the stems. You never want to skip stems just because you don't have any. Okay, the next thing I'm going to do is I'm going to notice that I'm using that last digit there, and there's only 1. So my stem is going to be the first 2 numbers, basically, and my leaf is the last digit. So when I go look up here at my numbers, I've got 73, so I'm going to put a little 3 right here after my 7, and 42, and 67. Okay, so I'm just going to, and then I get to 78, so I have another one, so I'm just going to line that up right next to, no commas, okay, nothing fancy. There's a 3 and an 8. I like to imagine, just like in class we've made a lot of posters putting stickers on, it's like we're making a dot or a sticker, it's just still labeled with the number. So we're really just stacking up values in the 70 category. All right, and so I've got a stem of 9 and a leaf of 9. I've got 84, 91, 82, 86, 94, and 100. So again, remember, we're using that last digit there, that 1's digit as our leaf, so that's going to be 100. All right, now I notice that these numbers are not in order, so if you want to rewrite them in order, you can. So you can make this 149 or 246 in this row, and a lot of teachers really want you to do that. But for us, if we're just making a real quick sketch to try to see the shape and any outliers, the center, the spread, we don't really need to use that as long as we're careful. What we do have to have, though, is a key. So I'm going to go ahead and write that. The key. And I'm just going to use this first number, but you can use any numbers you want as long as it works for your graph. I'm going to say 4/2 equals 42, and I'm just going to label this as test grade here. Okay, so there's really no unit. I don't know if that's points or percent or what. I'm just going to label that as test grade. Now, if we want to think about this in terms of what if we had to write about this now? What if we had to go through the socks? All right, so let's think about this. The context would be test grade, so we'd want to make sure that we mention the test grade when we were writing. And then we want the shape. Now, to get the shape, you're going to kind of turn your head. And basically, you want to think about this as a number line. So I think about the 4 as being on the left side and the 10 as being on the right side. So when I look at this, it appears that it might be sort of skewed to the left. So my shape would be sort of skewed to the left over there. Outliers, we might have this 42 as an outlier. It does seem pretty far away from 67, but I don't know if it's far enough away for it to be actually an outlier. So remember, in this chapter, we're just looking for things that don't seem to fit the pattern of the rest of the data. And next chapter, we'll actually calculate mathematically if we think it's an outlier. So 42, you might say, 42 may be a low outlier, but in the next chapter, we'll actually figure out if it is. What about the center? So this would be the median value, would be a good one for us to use for center. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. So if I have 11 values and I cut that in half, that is 5.5. Which means 5 on the left, 5 on the right, and 1 in the middle. So what we want for our center would be the 6th value from left to right. So I'm going to be really careful here. So I know I've got 2. That's 1, 2, 3, 4. But the 5th number is going to be 82 because I didn't do these in order. Okay, so I'm thinking from least to greatest. And my 6th number is actually going to be the 4 here. So my center would be 84 of a test grade of 84. As far as the spread goes, we could talk about the range. The range goes from 100 down to 42. 100 minus 42, that's going to give me a range of 58. Okay, so if I was going to write in complete sentences, I would say something like, the distribution of test grade is slightly skewed to the left with a potential low outlier at 42. Or if that doesn't feel low enough for you, maybe you say with no outliers. The center has a maybe not the center. The median value is a test grade of 84, and the range is a test grade of is 58 points. Okay, all right. So that one's pretty easy peasy. Okay, not a lot of special things hopping out of you. So there are a couple of special things that could happen. All right. So one of those things could be, I've got an example here. It says the reaction times on a test in seconds are listed below. So these are seconds, and I've got 2325. These are actually in order already. Yes. Okay. And then a higher one of 27.09. So again, I'm going to go off and do my little think strategy here. So I've got 23.25, and I've got 27.09. Okay. And again, I'm going to stop and think, what if I use the leftmost digit there? Okay, that's only a stem of 2 and 2. That's only one stem, which is definitely not 4 to 15. All right, so I'm going to think, well, let's go one more over. Go one more over, that gives me 23 to 27. 23 to 27, 23, 24, 25, 26, 27. That's 5 stems, and that's not too bad. So 5 stems would work, but I do have a small problem. I go over here to my leaves then, and I've got 2 digits as a leaf, and I don't want 2 digits as a leaf. So what we're going to do is we need it to be 1. Now there's some debate about whether or not you should round or truncate, but what we're going to do is truncate for a couple of reasons. The first reason that we're going to truncate is because it is faster. Truncate means we are literally going to ignore the last digit of all of these numbers. So when I see 21.25, I'm only going to read it as 23.2. 24.13, I'm only going to read it as 24.1. Okay, so again, it's because it's quicker to do it that way. Like, we are looking for a general quick graph that we can make to see center and spread and shape, and I don't need to take all this time rounding. The other reason why we don't want to round is because we don't know if these numbers have already been rounded. If these numbers have already been rounded to the nearest hundredth, we shouldn't round them again, and that makes us round each number twice. Okay, that's very gross mathematically. We don't want to round twice. We're not double rounding here, so we're just going to truncate that last digit. Now, some people would say, well, why can't I just split off that last digit like we did in grade school? Why can't I just split that off and say, 23.25 and 27.09? Why can't I just split it there and use those last as my leaves and not have to worry about truncating? Well, if we did that, our stems are going to be 232, because we're not going to put any decimals in there, up to 270. 232 up to 270 is a lot of stems, like way over 15. You're going to fill up your whole paper with stems. And you've only got a handful of numbers here, so it's going to be a very uninteresting graph. So we don't want to do that. We want to keep it smaller. So I'm going to go over here and I'm going to say stem and leaf. Okay, and I'm going to put stems of 23 through 27. 24, 25, 26, and 27. Okay, and then I'm going to go up and I'm going to truncate. So this one's going to be 23, and then I'm imagining that I'm just looking at that other digit there. That's going to be 23, 2. Okay, got that one. 24, 1. 24, 7. Okay, got those two. 24, 8. 24, 9. Notice that I'm not putting commas here, and I'm not putting any decimals. We'll deal with the decimal and the key. 25, 3. 25, 5. 25, 8. Okay. 26, 2. 26, another 2. And 27.9. 28.0. So I'm truncating off that last digit there. Now, when you go to do this key, you can, again, pick any number. I'm going to go ahead and say the key is that 23/2 is 23.2, and the unit here is seconds, 23.2 seconds. All right, so there's my stem plot. If I was going to talk about the shape of this, again, I kind of need to turn my head, and I'm going to look 23, 24, 25, 26, 27. You could say that this looks slightly skewed to the right. Most of the numbers are in the 24 range, and then there are three bars on the right of that and only one bar on the left. So maybe slightly skewed right. If I wanted to find the median, I could count. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm looking for the sixth number. 1, 2, 3, 4, 5, 6. So 25.3 is my median. And my range is what I would get when I take 27.0 minus 23.2. And that would be an approximate range, but you could get a better approximation using the numbers that you already have over in the data, okay? All right, here's another issue that might arise. So this says home prices in thousands of dollars. So we have 100 up to 290, and again, these are in order. So I've got 100, I've got 290, 100, and 290. And if I go to look at the first two values here, if I look from left to right, if I use the 100s place as my stem, I've got 1 and 2. That's not enough. That's too few. All right, so that's not going to work. So then I decide to say, well, what about if I use the next two digits? So basically making the tens position my stem. That gives me numbers from 10 up to 29. Okay, that's 20 values. That's really too many, especially with, there's just a very few numbers here. So I don't really want to make a ton of stems. So that's too many. So the first one's too small, too few, and the bigger one's too many. So what we're going to do is we're going to actually forget about this one that's too many. We're going to take the one that seems like it's too few, and we're going to split the stems. So essentially what that means is that we're going to have 2 1s and 2 2s. That'll give us 4. Those first ones, those are going to be the low values, like the leaves that go from 0 to 4. And the second set of ones, that's going to be the high values. So you think kind of like traditional rounding rules here. Same thing here, we're going to have the low stems that go, the low leaves that go from 0 to 4. And then we would have the high leaves that go from 5 to 9. Okay? All right, so I'm going to go over here. And also, if I do this, if I'm keeping this, I'm also going to have to truncate off that last digit. So essentially, our stem is going to be the 100s spot in our number, and the leaf is going to be the tens digit of our number. So I'm going to go over here, and I'm going to go 1, and I'm going to make myself a little note. This is the low, and then 1, that's the high, and 2, that's the low, and 2, that's the high. We're going to split those stems. All right. Forgive my terrible handwriting. Oh, look, I started to write my last name instead of leaf. Okay, this is why we can't have nice things. All right. So I'm going to go through my numbers, and again, I'm truncating. So I'm using the 1, 1, 0, and then 110 would be 1, 1. We've got 1, 1, 120. I'm truncating the last digit, so that's just 2. 1, 3, 1, 3, and 1, 5. Ooh, but 1, 5 would round up if we were going to round. So I'm going to put that on the high end because we kind of break it at that rounding rule. 4 or less goes up on the lower, and etc. All right, so 1, 5 and 1, 6. I'm going to continue this through. 1, 7, 1, 7, 1, 9, 2, 1, 2, 3, 2, 3, truncating, 2, 4, 2, 4, 2, 6 is going to go on the higher end, 2, 7, 2, 7, 2, 8, 2, 9, 2, 9. I'm going to go ahead and make my key. Here's another way that you can make the key. Instead of using the 1/what and giving an example of the number, you can say that the stem is equal to the hundreds spot, and the leaf is the tens spot of the number. So the key, the stem is the hundreds, the leaf is the 10 spot. So just like you're in grade school and you're identifying the place values of the number, you can make your key to look like that. If I do this though, I don't have a unit anywhere, so I want to make sure that I put that somewhere. I'm going to go ahead and write that the unit is thousands of dollars. Okay. All right, for context there. And a real quick note about some things that bother people as they're working on some of this truncating and splitting stems. One example that I've had students come up with in the past, and they say, well, I've got this number and I've got like 6, and that's the lowest number, and then the highest number is like 540. All right, so when I go to line those up, okay, I've got my 6 and my 540. I put my zeros in the front, and I start to look from left to right. Well, that gives me a stem of 0 and a stem of 5. So 0, 1, 2, 3, 4, 5. That's 6 values. That's plenty. But I go to truncate this, and the leaf I would use would actually be a 0. So if I had a 6 and, say, an 8, then I would have in my stem there, I would have a 0. And then I would have a 0 for the 6 that got truncated off, and a 0 for the 8. Because there is no value in its tens place. So you might see that kind of double 0 racking up there, and that's totally fine. Okay, so don't be afraid if you see that sort of thing show up in a problem. All right, so let's look at a back-to-back stem plot. So let's say I want to compare two data sets. And I know that if I was working with, say, a dot plot, then I would stack them and I would put the two number lines together. But in this case, when I make a stem plot, it doesn't make a lot of sense to stack them because you're building them out to the side. So instead what we're going to do is we're going to back them up back to back. We're going to put the stems in the middle, and then we're going to pull the one set of stems out to the right, or sorry, one set of leaves out to the right, and we're going to put the other set of leaves out to the left. So we're kind of growing both stem plots off of the center. This is the Unicef report. Says the Progress for Children included the accompanying data on the percentage of primary school age children who were enrolled in 19 countries in Northern Africa and 23 countries in Central Africa. All right, so at the time of this survey, for example, this 86.6 right here, what that's saying is that for this particular country, 86.6% of children who were old enough to go to school, who were the right age for school, were actually enrolled in school. Okay, so we want to compare these two sets of data. So the first thing we need to do is identify the smallest number and the largest number as a total of all the data put together. What's the smallest total number? What's the largest total number? So if I scan through, my smallest percentage is 34.4 and my largest percentage is 98.9. All right, so I'm going to do my little check here, and I'm actually going to scroll back up and do this up here. So 34.3 and 98.9. Here we go. I'm going to think about hacking off that first digit. That would give me stems of 3 through 9, which I'm totally fine with. Okay, 3, 4, 5, 6, 7, 8, 9 is between 4 and 15. That's great. But I am going to have to truncate off that decimal place. So I'm going to have my stems is the tens position of the percentage, and my leaf is the ones digit, and my unit is going to be percentage of primary school age children. All right, so 3 through 9. So I'm going to go ahead and in the middle of my paper, I'm going to go ahead and say stem. I'm going to draw a big line across here, and I'm going to go 3, 4, 5, 6, 7, 8, and 9. There are my stems. And I'm going to go ahead, and it doesn't really matter which one goes which, you just have to label them. I'm going to label the one on the right. This is going to be for Northern Africa. And I'm going to put the leaves on the left for Central Africa. All right, I'm going to go ahead and switch my pen color here. I'm going to do these Northern Africa numbers kind of in green. So I'm going to stem those off to the side here. Oh, and I moved my screen. This is extra fun. There we go. I think I fixed it. Okay, so I'm looking for the 5, and I'm going to cut that off. And so the next digit over is the 4. And again, remember, we're truncating off that tenths place, that decimal place. 3, 4, 4, 8, 7, 7, 5, 9, 8, 8, 9, 7, 9, 2. Okay, so I've gotten to there. 8, 3, 9, 6, 8, 8, 9, 8, 9, 1. Okay, now I'm to there. 9, 7, 9, 6, 9, 2. Let me see if I can move this over just a little bit. Okay. So here's that 9, 2. Okay, I've got a 9, 4, a 9, 8, and an 8, 6. Okay, 9, 4, 9, 8, 8, 6. Okay. And then I'm going to do the same thing over here for Central Africa, but I'm going to build those out to the left. So I'm going to do these in blue here. So 5, 8, 3, 4, 3, 5, 4, 5, 3, 8. Okay, that puts me to here. 6, 3, 5, 3, 6, 1, 6, 9, which I wrote, go, okay, 6, 1, 6, 9, okay, so I'm there. 4, 3, 8, 5, 6, 3, 5, 8, another one of those. 6, 1, 4, 0, 7, 3, puts me there. 3, 4, 7, 4, 9, 7, 6, 1, 6, 6, 7, 9, and 9, 8. All right, so there is my stem plot, my back-to-back stem plot. And we can tell by looking at these that these are not telling the same story. We can definitely see a higher concentration of values in the 90% for Northern Africa, whereas it looks like a higher concentration in the 60% for Central Africa. Also, I know I didn't put these stems in order, but you could always reorder them if you wanted to, or order them as you are working with this. But if you're just looking for a real quick measure of shape and any gaps and things that you have, as long as you're careful when you're finding, say, median off of this, we can see all of that information without having to worry too much about that order. And also with the truncating, we still have all of that information. So if we wanted to find the exact value of the median, the exact value of the range, if we're interested in interquartile range exactly, we have all of that data and we could still calculate it. The graph itself is just supposed to give us a nice quick visual image of what's going on. Okay, that's why we love dot plots and stem plots. They're super quick to make. Okay, it doesn't take us very long to make these. I do need to put a key on this, and since this is a back-to-back, I like to do my key with the 10s and the 1s kind of thing, just because I think it's easier to think about. So I'm going to say my key, my stems. Okay, now remember my stems were going to be the 10s place, and my leaf, that's going to be the 1s place. Okay, and then my unit is going to be the percent enrolled. Okay, so I know that this is like 34% enrolled, 58% enrolled. So you read it from the inside out as you're creating those numbers. Okay, so stem plots. Nice and easy graph to make. Okay, remember, you're not going to do this grade school style and just be hacking off that last digit. We're going to work from left to right. Our goal is to create somewhere between 4 and 15 stems, and that's guidelines. That's not a hard, fast rule. So somewhere between 4 and 15. If you're stuck between it being too few, move on to the next one. If you have too few and too many, you can split to create double whatever you do have. Okay, and you're also, we want 1 digit for the leaf. So if you end up with where you've decided your stems are, giving you too many leaves, or digits for your leaf, then just truncate it. Just cut it right off there. And again, the reason why we're not going to be rounding is because we don't know if these numbers have already been rounded, and we don't want to give ourselves permission to round a rounded number. That's a bad choice for us. Also, it's nice and quick just to truncate it off there. We're looking for shape, and so this is going to maintain that shape as much as possible.